Our Tennessee State Standard today is to know and apply the properties of integer exponents to generate equivalent numeric expressions. For example, 3 squared times 3 raised to the negative 5th power equals 3 to the negative 3rd power, which equals 1 over 3 to the 3rd power, which equals 1/27. Your lesson objective: I am learning to write and evaluate expressions using negative exponents. So you need to pause the video and write that down. All right, so here we have exponential form: 10 squared, 10 to the first, 10 to the 0 power, 10 to the negative 1st power, and 10 to the negative 2nd power. And we know that 10 squared is 100. 10 to the 1st power is 10, and we know that if we divide 100 by 10, that gives us 10. So each time that we divide by 10, our number is going down in value. So 10 divided by 10 is 1. 1 divided by 10 is 1/10. 1/10 divided by 10 is 1/100th. So I want you to look at this table and to see if you can come up with a pattern looking at the exponents and looking at the standard form of that exponential equation or expression, sorry. And we'll talk about that tomorrow. All right, so negative exponents: any non-zero number to the 0 power is 1. So if I ask you what's 1,365,298 to the 0 power, your answer would be 1. Any non-zero number to the 0 power is 1. Any non-zero number to a negative power is its reciprocal to that power. And remember, if you think way back to dividing fractions, when we actually multiplied the reciprocal, we switched the numerator and the denominator, or just flipped them upside down. So 7 to the negative 3rd power is the same thing as 1 over 7 to the 3rd power, 1 over 7 times 7 times 7. X to the negative n is the same as 1 over x to the negative n, where x is not equal to 0. All right, so if we want to write 6 to the negative 3rd power without using a negative exponent, what can I put this number over to where I won't change its value? What denominator can I give any number, or what can I divide any number by that won't change its value? Well, that would be 1. So now we can actually switch our numerator and our denominator. So the 1 goes on top, the 6 goes on the bottom, and just the act of flipping that gets rid of that negative sign. So 6 to the negative 3rd power is the same as 1 over 6 to the 3rd power. A to the negative 5th, once again, put it over 1, then we can flip it. 1 goes on top. A to the 5th power is your denominator. All right, more examples. So this gives us, and this says express using positive exponents. So once again, 1 over 7 squared. Oh, we know anything to the 0 power is 1. So this would be 1 over b to the 4th. And then m to the negative 3 would be 1 over m to the 3rd power. So we just give its reciprocal and get, that's what, when we get its reciprocal, then we can eliminate that negative sign. All right, if we wanted to evaluate expressions with negative exponents. Well, first of all, we know 2 to the negative 5 is the same as 1 over 2 to the 5th. And we know the exponents, that means that we have to multiply 2 by itself 5 times. 2 times 2 times 2 times 2 times 2, which would give us 1/32. All right, negative 4 raised to the negative third power would give us 1 over negative 4 raised to the third power, which equals 1 over negative 4 times negative 4 times negative 4, which would give us 1 over negative 64. Now, you will notice that in this, I actually wrote that with the negative 64 on the denominator. You need to get in a habit. Anytime you have a negative in the denominator, go ahead and write your fraction and either put it in front of the fraction like that, or you can put it with the 1. We do not leave negatives in the denominator. We either put it in front of the fraction like this, or we would put it with the 1 or with the numerator. All right, so evaluate the following expressions. Well, we know this is 1 over 3 to the third power, and if you have started memorizing your perfect cubes, you know that 3 times 3 times 3 is equal to 27. 4 to the negative 2 is the same thing as 1 over 4 squared, which is equal to 1 over 16. 2 to the negative third power is 1 over 2 to the third power, which equals 2 times 2 times 2 equals 8, so 1/8. And finally, negative 6 to the negative fourth power would be 1 over negative 6. We need to leave that in parentheses, to the fourth power. I'm going to have to multiply this out. So negative 6, we know that it's going to be positive because negative times negative times negative times negative equals positive, because our exponent is an even number. So let's see, 6 times 6 is 36 times the third 6. 6 6 is 36, 6 3 is 18, 21, so 216, that's to the third power. But we're going to multiply it one more time, so we'll have it to the fourth power. 6 6 is 36, 6 1 6 plus 3 is 9, 6 2 is 12. So that would be 1 over 1,296. All right, now what if we want to write expressions using negative exponents so that we don't have a denominator? Well, the same as we flipped it down on the bottom to get rid of the negative, we can flip it or use its reciprocal, flip it back up to the top, so that would be 5 to the negative second power. All right, so we need to know, is this a perfect square or perfect cube? We know that 36 is a perfect square because 6 times 6 equals 36. So now we have 1 over 6 squared, and when we find the reciprocal of that, that would be 6 to the negative second power. One over 8 to the third. We flip it and add our negative sign. 1 over to c to the fifth, we find the reciprocal, c, and add the negative sign to our exponent, so c to the negative fifth. So 4 is the same thing as 2 squared, 2 times 2, which would give us 2 to the negative second power. 27 is a perfect square or perfect cube? Well, we know that 27 is the same as 3 to the third power. We find our reciprocal, and that would give us 3 to the negative third power. One human hair is about 1/1000th of an inch in diameter. Right, the decimal is a power of 10. Well, first of all, we got to write it as a fraction. So 1/1000th. All right, then if we write that as a power of 10, we would have 1 divided by 10 to the third, because we have 1, 2, 3 zeros, to the third power. And then if we show that as a negative exponent, that would be 10 to the negative third power. All right, multiplying and dividing with negative exponents. Well, we know when we multiply, we add. So we have x to the 4 plus negative 2. And remember, I want to get down to just one sign, so plus negative is the same thing as minus 2. And that gives us x squared. All right, so here we have w to the negative 1 minus negative 4 because we're dividing. That really says negative 1 plus 4, so that would give us w to the third power. Or you can think about it this way. If you know that to get rid of the negative you flip, then we would put the bottom number on top, the top number on bottom, and then we know that when we divide, we subtract. So either way, showing your work there would work for that, whichever way makes sense to you. All right, more examples. So we have 3 to the 8 plus negative 2, or 8 minus 2, which equals 3 to the 6th power. N to the 9th times n to the negative 4 would be n to the 9 plus negative 4, or 9 minus 4, which is equal to n to the 5th power. 11 to the negative 2 divided by 11 to the 8th would be 11 to the negative 2 minus 8, which would be 11 to the negative 10th power, which is also equal to 1 over 11 to the 10th power. B to the negative 4 divided by b to the negative 7 would be b to the negative 4 minus negative 7, which is actually plus 7, which equals b to the third power. And that is the end of our lesson on negative exponents.